Hey Algebra 1 students, this is Ms. Krause here, obviously. This is your first flipped lesson. Since you finished your test, hopefully everyone met every standard and did a great job. We're going to move on to Chapter 2. Now Chapter 2 covers a lot of things from Chapter 1 that I think are pretty easy, so we're actually going to skip a couple sections and start off by looking at Section 2, 3, and 2, 4. Which are solving linear equations. And even this, I kind of front-loaded you guys. We did a lot of these, even harder ones than we're going to do today, earlier in the year, just to make sure that they were still fresh in your mind and you knew I was going to be expecting some harder work. So the way a flipped lesson works, okay, and the intention of a flipped lesson is that you do practice in class instead of doing it at home. So, for example, normally in class, you'd come in, you'd sit down, we'd do some notes, some examples together, and then you do all your practice at home. And if you did it right, then good for you. But if you made some mistakes when you went home, consistent mistakes, you've actually developed a really bad habit of doing something wrong. And it's a lot harder to fix bad habits than to just take some notes on your own and check in quickly when we're doing practice in class to make sure you're doing it right. So we're going to try this out. Your job, your only homework, is to make sure you have this sheet right here, okay? And we're going to do notes together. Right now, like we were in class, okay? Except obviously I'm not going to ask you questions because you can't answer them. So we're going to start off with this sheet. I want it in front of you. As I write things down, try to figure out where they would go in this sheet, okay? And I'll try to walk you through when you should be writing things and not, but it's pretty obvious. You guys would do fine in class. You can do fine now. So have this sheet with you. We're going to get started. So in this section, we're looking at solving linear equations. Now, linear equations mean that they don't have any squares in them. They're not rational. They might have a ratio. They might have some sort of fraction. But our variable is never going to be in the denominator, okay, and in the numerator of a ratio. So if we were to graph these, then they would look like a nice straight line. We're going to really focus on solving them, isolating our variables, and finding what our unique solutions are. All of these are going to be unique. We're not going to talk about no solutions today. We're not going to talk about identities. Those are things you should know. We're going to review next class. Okay? So, under where it says solving a multi-step variable, there's two things I want you to remember. The first thing you need to do is that when you start solving these to get your letter alone, get your variable isolated, what you want to do is you want to work backwards. So you're going to think, if I were to solve this, if there was no letter in it, okay, what would I do first, second, third, fourth? What would I do last? Okay? To solve these, you're going to then think of the steps you would do, and you're going to do them in the opposite order. So what you would do first is actually going to become what you do last to get rid of that number, okay? To isolate that variable. That'll make more sense as we do a couple examples together. So remember, we're going to be working backwards in the order of things that you solve, kind of like opposite PEMDAS. Something that you should know also, again, I want you to use the appropriate vocabulary. To isolate, you're very going to use inverse operations. Okay? And what that means is to get rid of addition, you're going to subtract it to move it to the other side, to cancel it out. If you have 2x, you're going to divide because that's the inverse operation of multiplication. This is nothing new. You guys know this. You're good at it already. So this is really like review. So let's look at a couple simple examples. Let's look at example 1. Okay. We're going to have the equation. I'm looking at my notes. So at this point, I should probably have that first box filled in. I'm going to look down here. I have 2a minus 6 equals 4. So thinking of these two things, I'm going to isolate my a. I know you can do this one pretty quick. We did it on Khan Academy like a month and a half ago. Easy ones like this. So we look, normally PEMDAS, I would multiply, and then lastly, I would subtract. Well, I'm going to work backwards, so I'm going to start by getting rid of this subtraction first. To get rid of a minus 6, I'm going to use my inverse operation. I'm going to add 6 to each side. Those cancel. Now I'm left with 2a equals 4 plus 6 is 10. Now I use my inverse operation to isolate my variable. Opposite of multiplying is dividing, so divide by 2. What I do to one side, I must do to the other. I get a equals 5. Nice, easy one if you remember from earlier in the year. That's called a unique solution because we have our variable isolated, didn't cancel out, and we get one solid number on the other side. Okay. Example 2, we'll make it a tiny bit harder. We have n plus 1 over negative 2 equals 15. So here, okay, normally I'd say, oh, we do addition last, but really if we had a 3 here, We would solve by grouping, right? We would do 3 plus 1 first, we get 4, and then we divide by -2. So technically, my last piece here, even though it's not order of operations per se, it's solving by grouping, I would do divide by 2 last. That becomes the first thing I'm going to get rid of, okay? Now, you see fractions, you hate them, but remember, like I've said, this is just a divide by -2. To cancel out divide by, we multiply, inverse operation, okay? So I'm going to multiply by -2 here, multiply by -2 here. Those cancel, the negatives and the 2. I'm left with n plus 1 equals 15 times -2. A positive times a negative is a negative, and 15 times 2 is 30. Now this is very simple. I have one step to get my n alone. I see that I have a plus 1. My inverse operation is to subtract 1 from each side. So I'm left with n equals, these are the same sign, so I'm going to add them and keep the sign, -31. Okay? And these are both of my solutions to this multi-step problem. We're going to move into some that are a little bit more challenging. Okay? So make sure you have the right answers and the steps in your notes in order to get credit. Add to it, rewind if you need to right now. We're going to go on to the second section in a second. Okay? The last 2 examples we did are as simple as it's going to get. All right? It's going to get a lot more complicated from there. So the next step to make it more complicated, and again, you've already done problems like this, is when we have copies of the same variable. Okay? And we're going to start off by doing the same variable on the same side, just a couple of them. Now the big idea to solve these, we have 2 bullets again. We're going to add on to what we had last time, which is the first thing before we start moving things around, is we're going to combine like terms. So right off the bat, you're going to notice that that variable is copied somewhere. It's happening more than once on one side of the equal sign. You need to take that expression and you need to combine all of your like terms. Take all your x's, put them together. Take all your n's, put them together. And remember, when we combine like terms, we're adding our coefficients or subtracting our coefficients. We're not multiplying them, okay? When we combine things, we are just adding those or subtracting those numbers in front. We're combining them. So, first things first, combine like terms. Second thing, you're going to work backwards and you're going to use your inverse operations. All right, so this was the previous step. Before we can do this, we need to combine like terms. We'll do 2 examples of this and then we'll move on to the harder, which is still easier than I think I made you do in the beginning of the year. 2 examples. Example 1. I'm looking at the middle of my notes now. I have 13r plus 5r equals 36. That does not say r, so we're going to add an r. There we go. 13r plus 5r equals 36. So, first things first, before we do anything else with working backwards, we're going to combine like terms. I have 13r's and 5r's. Together, I have 18r's equals 36. Now, at this point, it's very easy. I only have one inverse operation that I have to do. I'm going to divide by 18, because again, this is multiplication, the inverse is division. Those cancel, I'm left with r equals, hopefully you know, 36. Divide by 18 is 2. Again, getting a unique solution. Another example, a little bit harder, okay? We're going to have 3x plus 7, parentheses, 3x plus 4 equals 28. Now here we have several things going on, okay? We have our x's repeated. We have another property we're going to have to take care of before we can combine these like terms, okay? We need to simplify it as much as possible, and then we do our working backwards. So looking here, hopefully the first thing you notice is we have this 7. We need to use our distributive property to send it to each piece using multiplication. So this piece stayed the same, 3x. I'm going to add to it 7 times 3x, which is 21x. And then I'm going to distribute this 7 also to the 4, so I'm going to do 7 times 4, which is 28. Because it's positive, I'm going to add it. And then I get equals 28. Okay. Now, I still don't have it simplified enough yet. I need to still combine like terms. I see I have 3x's and I have 21x's. So together, 3x plus 21x, 24x, plus 28 equals 28. Now, at this point, there's nothing else I can simplify here. What I need to do is work backwards using my inverse operations and do the opposite order I would solve. Here, normally I would multiply in PEMDAS, right? So I'm going to do that last. It's inverse, which is dividing. I'm going to get rid of my plus 28 first by subtracting 28. Those cancel. I'm left with 24x equals 0. Okay? Now here, some people might be like, oh, something's wrong. It's not wrong. 0 is a number. Okay? You get it sometimes. Just like sometimes you get fractions and decimals and other rational numbers, you can also sometimes get a 0. So when we divide by 24 on each side, we get x equals 0 divided by 24, which is 0. Okay? Again, another unique solution. That's what we're going to be dealing with this time. One more section, a little bit harder. We'll take some notes, do a couple examples, and you'll be good to go. First flipped lesson, finished. So, hold on tight. Make sure you have all the work shown and your answers. If not, you're not going to get credit. All right. Lastly, hardest part is when we have multiple variables on both sides of the equal sign. We have a lot of things we need to do to figure out what our unique solution is. So, 3 big ideas here that I want you to know, 3 steps. The first thing, we're not necessarily going to combine like terms. That could be part of it. But what we're going to do is we're going to simplify each side of the equal sign. You should be like, oh yeah, I remember doing that. We draw our wall, okay? And we look, can I make this any simpler than it is? Can I make the other side any simpler? Simplify each side down. After you simplified each side down, okay, on either side of your wall, after that, what we're going to do is we're going to move your variable to one of the sides. Don't try to balance this equation with your variable on both sides. It's going to be a lot more complicated. You're more apt to make mistakes. So looking at them, you're going to ask yourself, okay, can I simplify this side of the equal sign anymore? No. Can I simplify that side? No. Awesome. Now I'm going to move my variable. I'm going to look. Which makes sense? Should I move my x to this side, or should I take the one from over here and move it over to the other? Okay? Make a choice that makes it easier for you. Math's about making smart decisions that make your computation easier. If you don't like negatives, make sure when you move your x's over after it's simplified, you're not dealing with negatives, okay? You've practiced this, you can do this. I know now it's going to be even easier than it was when we started this in the beginning of the year. So, after you've moved your variable to one side, your x, your n, whatever, is only in one spot on one side, now you're going to, work backwards and use your inverse operations. Okay? So first, simplify each side of the equal sign. Second, move your x's all to the same side. And then third, from there, start really working backwards to isolate your variable, get it all alone. So these are very simple problems. Each side of the equal sign has already been simplified. You've done harder than this. So let's just refresh our memory. We've been talking about functions. Let's get back in the zone of actually doing some of this real algebra. Here I notice I have w's on both sides. I draw my wall if I need to. I'm going to look. 3w plus 2. Can I simplify that anymore? There's no extra w's over here. I can't combine any like terms. I can't do distributive property. This is as simple as it's going to get. Over here, 7w. Well, yeah, that's as simple as it's going to get. So now, that's good. I'm going to look at my next piece. Move my variables to one side. I could minus 3w minus 3w. Or I could minus 7w minus 7w. I'm going to get a negative over here if I do that. I don't want to deal with negatives. You don't want to deal with negatives. Let's not. Okay? Let's subtract 3w's. That way, we're left with a positive over here. The idea being that those cancel. I'm now left with 2 on my wall. I'm going to put my equal sign. And then 7w minus 3w, 4w. Now I'm going to use my inverse operations. I'm working backwards to get my w alone. I'm going to divide by 4, divide by 4. 2 over 4 is not a whole number. It's okay. It's a fraction. Keep it as a fraction. All right? Fractions happen. You know that. You're going to see them. You're going to get them as answers. All right? This is our solution to this equation. Unique solution again. Over here, I notice I have x's on both sides. These x's look really complicated. There's fractions. This looks like some weird x over. It's an enumerator. I have to figure out what to do with that. But I'm going to start by looking at each piece of the equal sign right here. Can I combine my x with the 6? No, they don't both have x's. Can I do distributive property or anything else here? No, I can't. There's nothing else I can solve except for leaving it like this. And same with this side. I can't combine these things. All right? They don't have x's in common. They don't have anything that I can simplify. So now what I'm going to do, I'm going to go to my second step again. move my variables to one side. Now, before I move my variables all to one side, I can look at this and rewrite it in a way that's going to make more sense. Technically, the coefficient in front of this x is a 1. So I could look at this as 1/2 x. X divided by 2 is the same thing as half of x. Those two things are equivalent. You can always pull your denominator out and have your coefficient be the numerator of that fraction and put your variable beside it. Make this whole thing your coefficient, not just a divide by 2 underneath. Okay? So I'm going to rewrite it like this. 1/2 x plus 1 equals 1/4 x minus 6. Fractions happen. Okay? We still need to combine these. Now, if I think of money, would I rather have a quarter and take 50 cents away with it? I'm going to end up with a negative quarter, right? Or would I rather have 50 cents, 0.5, half a dollar, and take 1/4 from that? Well, I'd rather take a quarter away, and then I'm still working with positives. So I'm going to subtract 1/4 x, because I know 1/2 is larger. Those cancel. That's what I want to happen. I'm left with a negative 6 over here. This plus 1, nothing happened to. Now I have 1/2 minus 1/4. Now you should know that, okay? Again, you can think about money, half a dollar minus a quarter, or a quarter of a dollar. That's going to give us 1/4 left, okay? We're going to have 1/4 left with our x. If you didn't remember that, let's go over very briefly adding and subtracting fractions. Everyone needs a refresher once in a while. If I have 1/2 and I'm subtracting 1/4 from it, I need to make sure that I have a common denominator first before I do the subtraction. The common denominator between 2 and 4, least common multiple, is 4. Because this stayed the same, I multiply by 1, multiply by 1, this stays as 1/4. But here I need to look at my scale factor between 2 and 4 and multiply by 2 to get 4, so I must do the same to the top. I get 2/4. Now, to subtract, I just subtract my numerators. 2 minus 1 is 1, and I keep my denominator, 1/4. Okay? Sometimes they're not going to be so nice like 2 and 4. Okay, you're not going to be able to do it in your head so much. Maybe you're going to have fifths and thirds. You're going to need to find that common denominator, folks. Okay, fractions happen and you need to be able to work with them. So, over here we have 1/4 x plus 1 equals negative 6. My variables are all on one side. That's perfect. Now I'm ready to work backwards and use inverse operations. So, normally I would save addition for last. I'm going to get rid of that first. So, opposite of plus 1, minus 1. I have 1/4 x equals negative 6 minus 1, negative 7. Now at this point I can look at this two ways. I could almost switch it back to this original piece here, where I have 1x all over 4, okay? And I could say to myself, how do I get rid of this divide by 4? See how this 1/4 is similar to that 1/2, and we can just put that as the denominator? I can get rid of this division first. So the opposite of divide by 4 would be multiply by 4. Those cancel. I'm left with 1x equals negative times a positive is a negative, 28. Okay, and 1x is x, so that would be my solution. If not, we could always multiply. To get rid of this 1/4 that's being multiplied, we could divide by 1/4, divide by 1/4 over here. And when we divide by a fraction, we multiply by its reciprocal. So we would flip it, multiply our tops, multiply our bottoms, and we're still going to get negative 28. Okay, either strategy works. Fractions are hard for me, so I always look at it as two steps. The bottom means divide by 4, so to cancel out a divide by 4, I multiply by 4. And then here, to cancel out a multiply by 1, I could divide by 1, but it's not going to make a difference. So, these two. Lastly, on the sheet, we have a word problem. And it does involve a fraction. What I want you to do is take your time, read it over, give it a try. Okay? That must be done when you come to class on Tuesday. I need to see that you've attempted it. Okay? So give it a go. See if you can get it right. Thanks, guys, for watching. Hopefully your notes are complete, ready to turn in, get some credit, and you've done your first full lesson. Yay! Thanks. Bye. So I'm sure at this point you looked over the word problem and you went, I have no idea how to tackle this. Okay, so I'm going to walk you through it. You're welcome. For those of you who hung on, even though I said you were done, hopefully you're still watching it, and hopefully this will help you figure out what you need to do. So I read through the problem, and there were 3 pieces of important information. One piece was that there's a sale, okay, on, what is it? Water skis, sounds fun, okay? Sail on these water skis, they're 2/3 of the original price, okay? So you're paying for 2/3 of your original. Of is one of our key words we talked about earlier in the year. We'll talk about what that means in a second. He also used a $25 gift card, so he had an additional $25 off that original once they found the 2/3 of it, and that he paid $115. So we're going to set up an equation to figure out what was the original price. Okay, so we're going to call the original price variable P. You could choose X, Y, whatever, it doesn't matter. Okay, so we're going to think, in the end, okay, if we're writing an equation, in the end of this whole shebang, after we do all the work we need to, he pays $115. So that's going to be like our outcome. Okay, the outcome is that he paid this. Now, we have two chunks here. We have this piece that has to do with our original, and we have that he used a $25 gift card. Now, you know how gift cards work. You take whatever price it is, and they subtract it off of the price. Okay, so whatever the price is when it's 2/3, we're going to subtract off the amount of this gift card. Our equation is going to have a -25 over here. Okay, I'm going to write this equation and then solve it to figure out my P, my original price. Over here, we're going to use the 2/3 of our original price. Now, the word of is like the word per. Okay, it can mean a couple different things depending on what the context is. It could mean multiplication, it could imply division. If we're talking about miles per gallon, okay, we would do miles divided by gallons. Here, if we're looking at 2/3 of the original, of is going to imply multiplication. So we're going to do 2/3 times our original price, 2/3 of that original price, okay? 2/3 of our P, we multiply those together. So now we're going to solve this equation to find out what our original price was. To cancel out this -25, we're going to add 25 to each side. We have 2/3 P equals 140. Okay? Now we need to get rid of this fraction. Two strategies. You can divide by 2/3, divide by 2/3, which at that point you're going to flip your 2/3 to 3/2 and multiply your numerators, and you'd put a 1, you'd multiply your denominators. I like looking at fractions as two parts. It's quicker for me to do the math. I'm going to look at this as a divide by 3. So to cancel out a divide by 3, I'm going to multiply by 3, and I'm going to multiply over here by 3. Okay? That way I'm left with 2P equals 3 times 0 is 0, 3 times 4 is 12, 3, 4, 420. Now I divide by 2 to get my P alone. I find out that my original price is going to be 420 divided by 2, $210. Okay? So 210, if we multiplied it by 2/3 and then subtracted 25 more, we would get our 115 total. So steps to do this, because we're going to always be doing word problems, okay? You need to be able to take this math and apply it to something. Here we had to do a couple things. We had to write an equation, then we had to solve it. Solving's easy, writing's hard. You always pull out the important information. If there's a number attached to it or a fraction or something attached to it that seems mathematical, you probably want to write it down because it could be pertinent information. They could give you extra stuff just to mess with you, but initially I'm going to only give you information that you need to solve the problem. So I'm going to write down those 3 things. I'm going to ask myself, what is my answer piece? Is it my variable? Is it a number? Is it this number? What makes sense to be on the other side of the equal sign all by itself? And here, the 115, that's how much he paid. That was his total at the register before taxes, okay? That's by itself. And from there, I'm going to think, okay, he had a gift card. He used it. That means from whatever price he was going to have to pay, he minus 25. And then I work back to this. You need to know this vocabulary, okay? Of, difference, quotient, product, per, split. All of these are normal words we use that imply certain types of mathematics. And of, in this case specifically, is going to mean that multiplication. Okay? So if you hung on tight, now you're really done your notes. And you can put it away nicely knowing that all your answers are right. Okay? Thank you folks again. Have a good night.